Good morning, everybody. Welcome to H&V News's first heat pump question time. I'm delighted that we're able to tackle this subject, very important subject, something everybody's talking about, and I'm glad that we have an opportunity to hopefully to guide you through the mists of myth and give you some facts. We're delighted also that this event is supported by Daikin, so we'll be seeing Daikin experts giving you their take on things, but they also want to hear from you, and we can't have a question time without questions. We've shamelessly stolen the BBC formula where we need questions from the audience to talk about. So please use the Q&A box, not the chat box. You can, if you want to chat about stuff on the chat box, you can. But if you want a question to the panel, please use the Q&A. The panel are all there in front of you. We're showing you who we are first of all, and then they will fade away into the background until Iain has finished his presentation. He's got a lot to get through, and so we will, without further ado, the rest of us will all mute and black out our videos, and the floor will be Iain Bevan's. So Iain, over to you.
Thanks, Andrew, and thanks for the invitation. As Andrew says, I've got a bit to get through, so I'm going to push on. I'm just going to share my screen, and hopefully we can get going. A second.
Yeah.
Okay. Hopefully we're good.
Yeah.
Excellent. Thanks, Andrew. So, as Andrew says, we've got a bit to get through. I'm going to try and get this all done in the next 25 minutes. We're going to look at the market. We're going to look at legislation and funding and what's driving that market and where you can go to help develop this low carbon business of ours. And then we're going to have a look at some of the challenges from an industry point of view and from manufacturers like ourselves from our point of view. Then I'm going to change hats and go from Iain Bevan, Commercial Director of Daikin, to Oliver at Hayfield Homes, which is a developer that we've been working with for some time on their transition from fossil fuel heating to low carbon heating and some of the challenges and rewards, hopefully, that they're seeing from it. So we'll make a start. So as I said, we're going to look at the air-to-water heat pump market, how it is today, how it might look in the future. We're going to look at funding and legislation for both for private and social housing. And then some of the challenges, and as I say, the challenges from our perspective as a manufacturer, but also from installers, consumers, and what we see in front of us. So looking at installer support, awareness, heat pump awareness, availability, and connectivity. So let's just have a look at the market, and hopefully some of you will have seen this slide before. This is taken from the Heat Pump Association's publication, a roadmap for the role of heat pumps, which was developed back in 2019, and some of the panelists on this call had a big input into that, so hopefully I'll do them justice. But the first thing you can see from this graph is the sharp incline in expected heat pump sales. And as you know, the government have their own target of at least 600,000 heat pumps per annum by 2028. If I look at the market today, and my estimations for this financial year is the market will finish somewhere between 60 and 65,000 heat pumps at the end of financial year 22. So still a considerable way to go to get to the 600,000. And then, as it says at the top there, we should be installing over 1 million heat pumps per annum from 2030 onwards. So a big market opportunity in front of us, and that presents the challenges that we're going to look at shortly. The heat and building strategy gave us some headlines, if you like, some things to look out. And as I've already mentioned, this commitment still remains for 600,000 heat pumps per annum in 2028, and everybody's working towards getting there. There's the discussion about the phase out of high carbon fossil fuels off the gas grid network, and for sort of non-domestic business buildings, There's still talk around 2024, and for residential buildings around 2026. We're looking at still no new gas boilers from 2035, which is a huge change. And then recently they introduced the boiler upgrade scheme, effectively to replace the renewable heat incentive, which was a £450 million fund with financial support to help those able to pay in the market to switch from boilers to heat pumps. There's discussions around what was originally called the market mechanism proposal from 2024 onwards, which is aimed to drive those bigger heating manufacturers to increase their contribution of low carbon heat. We've had confirmation of social housing grants, the home upgrade grant, the local authority delivery scheme, and more recently the Heat Pump Ready programme, which is a £60 million programme designed to help make heat pumps easier, if you like, to get them into the market, try and unblock some of these blockages. So some of the clear headlines for us are in front of us. Manufacturers, installers, specifiers, consumers, we're all working to build this low carbon future. And these give us a bit of headlines along the way. Get my slide to move on. So we'll take a look at some of the funding. So we'll start with the local authority delivery scheme. It was a follow-on from the Green Homes grant, as we mentioned, but the LAD element, or the local authority delivery element, was around £500 million. It was split into 3 phases, 1A, 1B and 2, and these were originally due to end 31st of March 21, 30th of June 21 and 31st of September 21. It was for all 10 years, and EPCs targeted E, F and Gs. It's for households on the lower incomes, so with a combined income of no more than 30k, and it was 100% subsidy for owner-occupiers up to £10,000. 2/3 subsidy for social and private landlords, which is up to £5,000. The deadline was extended to the end of September 2022, and some of those projects are still running and still finishing off as we speak. We also had the Sustainable Warmth competition, £500 million, or just short of, which was opened and closed over the summer of 2021. This £499 million is made up of LAD 3, or Local Authority Delivery 3, which is £280 million, and HUGS 1, we love an acronym, the Home Upgrade Scheme, which was £219 million. It was open to local authorities and regional energy hubs only. Again, focused on the poorer insulated homes, with EPCs of E, F and G. And the LAD delivery part was aimed at the on-gas grid properties with a £5,000 to £10,000 grant. And then the home upgrade scheme part was aimed at the off-gas properties with grants between 10 and 25,000, again, based on the EPC band and your existing fuel. There's live schemes out there now that took advantage of the Sustainable Warmth competition. And BESA is still talking to some of the local authorities that were unsuccessful with the original bids to see if they can do anything in the short term. But the completion date is still aimed as March 2023, but there is still time to make some switch to heat pumps on the Sustainable Warmth competition. And then we move to the Social Housing Decarbonisation Fund. And this was part of a huge £3.8 billion fund, which is, like everything, subject to spending reviews. But the first waves of 62 and 179 million were released. But wave 2.1, which is 800 million, has been confirmed, and it was launched on the 29th of September. It was an 8-week window, which is now closed, but there's still opportunities for social housing providers to take advantage of this decarbonisation fund. As you'd expect, it's targeted at social housing providers, so housing associations and local authorities, and also registered charities. It's targeted at Band D properties and below, but some B and C properties are included, but only 10% maximum. And you're also allowed up to about 30% private homes. There's a sliding scale of grants between 5 and 16,000, depending on the EPC band and the wall construction of the property. And there's some additional funding available for low carbon heating, so another £7,000. Social housing providers have to contribute 50% of the cost, but low income private properties can be 100% funded. The important thing is an additional 15% allowed on top of those capital costs for admin and ancillary costs. Because like all these schemes, for any social housing provider, if you can bid for the money, then you've got to get the residents on board, you've got to get people interested and wanting to have a heat pump in their property. And that includes promoting the scheme, getting people in to help promote the scheme, surveys, etc. So the ancillary costs can help towards that. Heat pumps and hybrids are fully supported, and on and off gas schemes are included. The bids need to be 100 properties minimum, and it's a fabric first, worst first, least regret approach. But a lot of these bids are in now, and we'll soon start to see who's been successful, and they can start delivering against some of these schemes. As I mentioned earlier, we have the Home Upgrade Grant Scheme, or HUGs, as you'll hear it referred to. And that's part of this huge fund, the £2.5 billion fund. The first waves is 290 million, and wave 2 is 700 million, again, confirmed and launched in September. The funding rounds at 18th of November and 27th of January. This one's targeted more at owner-occupiers in the private sector. It's an off-gas scheme, and it's targeted at Band D properties and below. They do allow up to 10% social housing, and again, there's a sliding scale of grants between 5 and 16k, depending on the EPC band. Private landlords have to contribute 33% of the cost, and social landlords 50% of the cost. And again, low-income owner-occupiers can be 100% funded. Importantly, the additional 15% is allowed here as well to cover those admin and ancillary costs. And work needs to be delivered between February 23 and March 2025, so a wider window to get this work delivered. Heat pumps are fully supported, and bids need to be a minimum of 500k. Again, it's a fabric first, worst first, least regret approach. So we have two schemes running, one for the social housing providers and one for private owner-occupiers in the private sector. I mentioned earlier the boiler upgrade scheme. This was effectively the replacement for the original renewable heat incentive. It started from the 23rd of May, although applications could be backdated to the 1st of April. Basically, it was a move away from the payment to the end users being spread over a 7-year period to an upfront £5,000 flat rate fee. It was felt this would be easier for consumers to understand. If my heat pump installation costs X, I can get £5,000 knocked off that, so it helps with that initial capital cost. It's aimed at a 3-year scheme, around £450 million, and the target was for 90,000 installs. It's in England and Wales only, as Scotland have their own Scottish loan and cashback scheme, and Ofgem is the scheme administrator. It's for retrofit, so no large-scale private new builds, although individual self-builds are allowed. There's a capacity limit of 45 kilowatts on the heat pump, and a minimum seasonal coefficient of performance of 2.8 is required. Social housing is excluded because they're expected to use the social housing decarb fund, and hybrids are not currently supported in this boiler upgrade scheme. It's an installer-led process, which was a change from the original RHI and felt to give installers an easier route to getting this money. And the installer and the products installed need to be MCS certified. All fuel types are supported, except moving an existing heat pump to a new heat pump. So it's another opportunity for installers, manufacturers like ourselves, and UK PLC to try and raise awareness and accelerate this move to a low carbon future. We also have the Energy Company Obligation, or ECO, again, another acronym. It's this time ECO 4, there's a significant increase in funding. It's now around £1 billion a year for 4 years, which is up from around £600,000. In previous iterations of ECO, the main focus has always been on insulation, double glazing, and putting in more efficient or newer boilers. But ECO 4, there is a definite push towards air source heat pumps. So much fewer gas boilers are allowed under ECO 4 and more low carbon heating. Obviously still insulation, double glazing, etc., but a very distinct push towards air source heat pumps. As at the time of writing, there was still some detail waiting for this, but now we are actually starting to see some installations happening under ECO 4. Again, focusing on the lower EPC band homes, so E, F and G, but it's for the social and private sector. still a fabric first approach, which is the right approach, and is multiple measures allowed. BESA's own impact assessment estimates that there's probably around 68,000 eligible properties for a heat pump under the Eco4 scheme. So another big opportunity for us to make this transition to low carbon. The Warm Homes Fund is another fund that was originally launched in 2017. There were around about 21,000 heating systems installed and about 30 million funding realised for fuel poor households. The current funding round closed on the 21st of January, but there's a Connected for Warmth scheme currently running, which offers a fully funded boilers or heat pumps. It's for owner occupiers again and private tenants, but not social housing. It's in the Cadent gas area only at the moment, and it's for first time central heating installations. But again, it's just another example of there is money out there for this transition, and it's just knowing what's available, how to get your hands on it, and how to utilise that to help this transition. I mentioned the Heat Pump Ready programme earlier. The Heat Pump Ready programme is part of BESA's £1 billion net zero innovation portfolio, and it's really aimed to accelerate the commercialisation of these clean energy technologies. And it's not just about grants to install more heat pumps, it's money to help look at the processes, how we make it easier for consumers, how we make it easier for installers to go from that decision of, I want to make this change, how easy and quickly can we make that for everybody in that chain? It's a key solution for decarbonising homes, and heat pumps will be critical for meeting the targets that we've got. The Heat Pump Ready programme, as I say, will support the development of these new solutions right across the heat pump sector. It's aimed at trying to improve the customer journey, improve awareness of heat pumps, access, and remove some of the barriers that we see as we make this switch. Hopefully, it's aimed to help them reduce costs through streamlining the current process. And it's aimed to obviously help the government meet this target of 600,000 heat pumps by 2028. As well as all the funding, there's the legislation. The two key bits of legislation really at the moment around the building regulations. We as manufacturers are already starting to see a lot more interest and a lot more detailed discussions now with some of the larger national house builders as they get ready for this change in building regulations. The government's confirmed that the future building standard in England and Wales will be implemented from 2025, and it will focus on low carbon heat and higher fabric standards. In June, we saw an uplift on the current building regulations, equating to roughly a 31% CO2 reduction in comparison to the 2013 standards. This was implemented really to help increase the energy efficiency standards in the short term, but also prepare that sector for the forthcoming changes in 2025. And these will include the primary energy and CO2 or carbon metrics as the principal performance metric. In Scotland, the Scottish Government, slightly different, still trying to drive the same path. They're committed to ensuring that their new buildings use heating systems which produce zero direct emissions at the point of use. They're going to move away from their 5 notional buildings to 2, and it's based on heating type. So there'll be a specification based design based on the use of a heat pump for space heating. But for non-heat pump solutions, there will be a design based on efficient gas boiler with an energy demand offset by using on-site PV generation. And the notional building that they used to have for oil, LPG and biomass, they'll be removed completely. So if a new building can meet the heat demand by using a zero direct emissions only, then there will be an exemption for them from demonstrating compliance with the target emissions rate. They're also proposing that if a heating system is installed in a new building or replaced in an existing building, that the system should be designed and the emitters sized to operate at a mean water temperature not exceeding 55 degrees. So again, helping us on these steps towards these higher standards as we move forward. So that was a whistle-stop tour of funding and legislation, and some of the panelists on here are probably more in tune with that than I am. So I'm sure they'll mention if I've missed anything or if there's any mistakes in there, but hopefully it wasn't too many. All these changes as we move forward, you know, they do present challenges. Our fossil fuel, high carbon industry has been built up over the last 40 to 50 years, and we're trying to change this industry, this sector, to a low carbon, low temperature, sustainable industry in the next 10. So everything that we have today, the infrastructure, the awareness, the training, the skill set to make that change that's been built up over that amount of time in the next 10 years, as you would expect, quite rightly, comes with its own challenges. So I just want to look at some of those challenges from the point of view of a manufacturer, but also how it impacts on specifiers, installers and consumers in the UK. And one of the first things is products. We're constantly looking at the products. How can we make these products simpler to install, easier to service and maintain, easier for the consumers to use? You can make a technically advanced product, but if the interaction between that and the consumer isn't there, then you're not getting the best out of the product. And for example, us and many other manufacturers are moving our development a lot closer to the UK. And here at Daikin, we've just invested in a new research and development centre, or European development centre in Belgium, where we're now employing 450 people who are just continuously looking at the design of our products and how it impacts on this low carbon transition, not just in the UK, but across Europe. So within the wider now Daikin group, the European Development Centre is the key centre for our heating products as we move forward. Another vitally important area is training. Installer training is vital. These installers, having come from traditional gas boiler, fossil fueled installation, they know how to install those, they know how to price them, they know what to look for. As they move forward, manufacturers, colleges, etc., have to be there to help these installers make that transition. So installer training is vital. It needs to be flexible, with the ability of classroom training, online training, or even remotely at on-site locations. We should provide training for all stakeholders on heat pump design and application. So as well as installers, there's people designing heat pumps, there's people selling heat pumps, there's people talking to consumers about heat pumps. We need to be there to help them with their training and knowledge. Training for on-site sales consultants and product familiarization training for house builder staff in particular, but site managers, customer service teams, and homeowners if necessary. So we need to continue to develop and deliver training, and in particular, some of the industry accredited qualifications which are now being developed, which are vital as we move forward. So things like the heat pump foundation course, the low temperature heating course, we need to start seeing more and more installers signing up for this, and manufacturers like ourselves 100% to support it. Once an installer has been trained, it doesn't make them an expert in heat pumps all of a sudden. So manufacturers like ourselves, we have to be able to try and support those installers in terms of pre-sales technical advice. So if they have a question, or if they need some advice, if they stood in front of a heat pump and it's not doing what they would like it to do, we need to be able to support that. Because like anything, most installers will learn as they start installing. You can put them in a classroom for 2 or 3 days, and I haven't done it myself, but then they still have to get out to site, which is a totally different environment, and start installing these units. So the support that comes after that is crucial. And again, manufacturers like ourselves are investing in that. We've just developed our national heating hub in Birmingham, which is now a dedicated heating building. And within that office, we have pre-sales technical people who can offer installation advice, help with product selection, application, and quotations. But we also have internal account managers who can speak to those customers and help them with their order, deliveries, etc. On top of that, we need to offer help with heat and design. So we, along with lots of other manufacturers now, offer a heat and design service, which is available for new build projects in particular. It's a completely indemnified design package. It includes heat losses, hot and cold water layouts, radiator and equipment schedules, and heat pump selection. So again, for those bigger projects, there's support available there, which needs to be there. And then there's software tools. So again, once those installers and specifiers are out in the wide world, doing what they do best, as well as the technical support, we have to give them tools to help carry that out. So again, here at Daikin, we have things like our Stand By Me system, which covers the Heating Solution Navigator, which helps installers select the right heat pump for a job. It also covers warranty registration, installation registration, but also things like the EK mobile app, where an installer can have that app, can scan the heat pump, can look at a fault code, and that from there we can identify what's the possible fault, how to check that component, is the component working or not, how to replace it, what component you need. So again, trying to help as we make this transition. So you should be looking for those tools as you move forward. Consumer awareness is also another big challenge. We're used to, and we know what boilers are, we know what they do, and we know where they go. But Daikin is setting up sustainable home centres around the country, which is a place for consumers to go to see, hear, get advice and support on heat pumps. We're now up to 40 centres around the country. They include a showroom, they include regional training centres for new installers, and there's also stock there, so installers can buy equipment from those centres as well. We need help from the government. We talked about the funding that's available, and long may that continue. The government are committed to reducing carbon, but we need to see an continued increase in green policies and strategies as we move away from this reliance on fossil fuels. We need to see continued funding, and we need to keep lobbying on the removal of some of the levies on the electricity costs so we can balance up those fuel costs. We need to look at things like demand side response, time of use tariffs, grid balancing, all backed by smart heat pumps and smart controls. So we need to see these things to keep coming. I'll move on quickly to availability. All manufacturers have to start gearing up as this market grows. Again, not just in the UK, but across Europe. So currently, just in Daikin's case, we have 12 factories across Europe producing heating and air conditioning. We've just commissioned a new factory, which is a heat pump dedicated factory, 300 million euro investment in Poland. It's a 320,000 meter squared factory, and we will aim to finish that factory in April 2024. That will only make heat pumps and has the capacity to build 250,000 heat pumps per annum. So we have plans in place already to help us gear up for this change. If we look at the market, by 2025, we can see there's going to be more than 3 million units sold across Europe in the space of the next few years. By building this factory and increasing some of our existing production capacity, Daikin certainly will be able to build 4 times more heat pumps by 2025 than we can today. And it's been about a £1.2 billion investment in the new factory plus our existing factories. So manufacturers like Daikin are gearing up for this increase in growth. And then finally, connectivity. The energy market's changing fast. There is a current gas crisis and there's a gap. We need to remove these levies on electricity if we're going to hit this 600,000 target by 2028. So we have to look at things like time of use tariffs. It's designed to incentivize customers to use more energy at off-peak times. We have to look at things like demand side response, where we can intelligently use the energy, particularly if it's connected with solar PV, battery storage, so we put less strain on the grid. PV optimization is also important to prevent any unused generation being exported but used back in the property on the heat pumps. So we have to look at our heat pumps, the technology and the connectivity to make that happen. So the future could be a fully connected heat pump with solar PV on the roof, battery storage in the property or thermal storage, and an electric vehicle. We need to link all these things together. The heat pump can use the energy from the PV or the battery, or even maybe even the electric car charger. All energy generation is used then, and off-peak electricity can be maximized. So this could mean lower energy bills, reduced levels of fuel poverty, certainly lower emissions, and certainly will help towards this mass rollout of heat pumps. But that's why we as manufacturers have to look at how we can connect our heat pumps, which is just one piece of technology, to this sort of low carbon ecosystem. So I'm running slightly behind time, apologies, but there's an awful lot to get through, as you can see in the short space of time. But I just want to finish off with an example of a house builder that we've been working with for some time, called Hayfield Homes, who decided to make the change from high carbon, high temperature fossil fuels to low carbon sustainable systems. So I'm now Oliver from Hayfield Homes, and as this slide says there, why did they decide to make that change? Well, it was an exec board decision to be an early adopter and try and get ahead of the building regs. They've seen a 62% reduction in their target emission rates for CO2 against the regulations at that time. So Hayfield are a forward-looking builder. They're looking to do something different, and it was their exec board that made that decision to move wholesale to heat pumps. Their first site was at Stanton Harcourt in Oxfordshire. It was 63 homes and a community centre. They made that decision because there was no gas in that village, and there was an excessive cost to organise a gas supply. For LPG, that was an ongoing cost for the consumers, and it was unsustainable. So they made that decision to go with air source heat pumps on this first site over in Oxfordshire. Previously, their specification was for the private development homes. It was a boiler and a cylinder, an underfloor heating with radiators on the first floor. On the affordable homes, it was a combi boiler with radiators throughout. But when they moved to Stanton Harcourt, they changed the private homes from a boiler and a cylinder to a refrigerant split air source heat pump with a cylinder. They still use underfloor heating with radiators on the first floor. On the affordable homes, they went to a monoblock heat pump with a cylinder and radiators throughout. So really the only things that changed were the heat engine. So they kept the radiators and underfloor, they just changed the heat engine to a low carbon heat engine. First of all, you have to look at the design challenges. So for the house builders who've been building houses with boilers in for eons, have to start thinking about, okay, where do we put an external unit? In the case of a refrigerant split, we need to locate an indoor unit, a hydro box, in their case, on the private development homes. But that can take the place of where perhaps a boiler used to be. They have to locate in a cylinder, but again, in this case, they were already using cylinders, so it wasn't too much trouble. On the affordable properties, the challenge was space. They were using combi boilers, so they had to find space for a cylinder and make sure they could build that into the home without impacting on, obviously, the living space. And the external unit is always a balance between planning and the customer perception. You know, do they want that external unit right outside their back window, or do they want it down the bottom of the garden or beside the garage? And these are the things that they had to consider. Some of the key learnings they had was, again, the location of the outdoor unit. Do they hide it away, or do they put it alongside the house? If you hide it away, there's the practicalities of piping and wiring that system back to the property. They were using split refrigerant heat pumps, so they could move them further away from the building. That involves obviously copper refrigerant pipework, ducts in the ground, and making sure the units are protected. The ducts in the ground were being installed by the ground worker, and ground workers generally don't worry too much about how clean or how water-free or how airtight those ducts are. So we found a lot of instances where the refrigerant duct was full of water, full of mud, and as you can imagine, that has a detrimental impact on the performance of the heat pump. There's also protecting the units while they're on site with builders, and again, ground workers, as you can see in the picture there, bashing around with their machines, and they're not adverse to wiping out the heat pump unit. So site issues for them were protection of the unit while there was work being carried out, damage to the ducts. You can see an example there of some quite seriously damaged refrigerant pipework in the ground, and that unit is expected to work as normal, which obviously it's not going to. The installation of the outdoor unit is quite heavy, so handling of the outdoor unit was again something that they had to consider. They moved to the monoblock system, so that took away the need for refrigerant pipework, cut down on the distance for the ducting. It also took away the need for hydrobox inside the unit, so there was more space in the kitchen and the utility room. They can still locate it remotely from the building. Again, you just need to be careful of how and where you run that pipework. If there's ductwork provided, we don't want water in there. It needs to be nice and dry. So the trade-off was it's a slightly bigger unit outdoors, but far more space indoors and a bit more flexible or less areas for damage, if you like, with the outdoor unit. So the halfway house they've moved to now is a monoblock heat pump with a pre-insulated duct. So they still have some install problems, but the solution is to install now closer to the house. As consumers become more aware of heat pumps, and Hayfield has said themselves, we're making a statement to say, look, this is what we're using to heat your home. It's sustainable, it's low carbon. We're not going to hide it away anymore. We're going to trumpet it from the rooftops, if you like. So they still have some issues which they're working on: customer perception and understanding of how a heat pump system works, but basically understanding it just provides heating and hot water, like your boiler used to, but just in a different way. They're still challenging, or they're still tackling some of the challenges of training and familiarity for installers. They have a subcontractor list. Some are more experienced than others now at heat pumps, but they still find there's issues arrive on site as those installers get used to heat pumps. So I think that's Oliver's presentation in a nutshell. You can see some of the lovely pictures there and some of the challenges that they've had, but slowly working together with us, you know, we're improving the installed quality. We're talking more to the ground workers. We're talking more to the site agents, and they're getting much better at eliminating these issues, exactly as they did with combi boilers, you know, all those years ago. So we're certainly heading in the right direction with builders like Hayfield. So I think that's everything. You'd be glad to know. I didn't run too far over time, Andrew, so hopefully that wasn't too bad.
You within acceptable parameters. Yeah.
Thank you very much.
So thank you very much. Now the rest of the panel will start appearing. As we do that, yeah, do you want to clear your screen, Iain, as well? As everybody else starts to appear, I'll ask you one question, Iain, and that is, from your point of view as a manufacturer, how has the journey been so far? Has it been harder than expected, as expected, or see anything else? You're on mute though, you see, and that's the first broken the first rule of Zoom there.
That was one of the biggest challenges, is learning how to use Teams and Zoom.
Yeah.
No, it has been probably more difficult than we thought. I mean, my background, I've been at Daikin now for sort of 12, 13 years, but prior to that, I had my own plumbing and heating contracting business. So, you know, I was that company putting in boilers. And prior to that, I worked for the Valent Group, you know, talking and selling and promoting boilers. So I came to Daikin thinking, well, this is easy. We'll just change from boilers to heat pumps. And then here I am 13 years later thinking, and maybe it wasn't as easy as we thought. But I think that's because we can't underestimate the challenge. You know, as I said earlier, we are moving from an industry that's been developed, you know, over the last 40, 50 years, maybe more, you know, to a completely new way of doing things in the next 10, you know, so it should come with challenges. And I think we've just got to embrace those really and get on with it. And Hayfield is a good example. They made that decision. Their board made that decision. We explained at the time, you're probably going to get some learnings on the way, you know, but they're working through those. Their subcontractors are now better at it. Their site agents are now better at it. Their sales consultants understand it better. So slowly, the issues become less. It becomes more normal for them. But that's probably taken, just for that builder, you know, probably 12, 18 months. And we still see the odd, you know, the odd problem. So, and we're going to see that as the bigger house builders come into it, they're going to have the same learning. So yeah, it's probably been more difficult than I thought it was going to be 12 years ago, but it's certainly worth the journey, I think.
Thanks, Iain. Yeah, well, your presentation proved that there's certainly a lot to get into, and so that's what we're going to do now. I'm going to get the panel to introduce themselves, therefore that way I don't mess up their titles because they change regularly. We'll start with Graeme, and he'll tell us, I know he's got something particularly on his mind about the conveying of information at the moment. Graeme.
Good morning, Andrew. Good morning, all. Yeah, I'm Technical Director at the Building Engineering Services Association. Yeah, some good presentation there. Some good stuff on that, Iain. I think you probably touched on a lot of what I've been thinking. I wrote a few notes down. Really concerned about misleading stories in the mainstream press. You know, you talked about the perceptions of the householder. It's really, really important that we stop the scaremongering in the mainstream press. And I'm not just talking about the tabloids here either. Quite worryingly, in the recent months, we've had some really awful stories in the likes of the FT and the Guardian. So getting that message across is really difficult. I think, you know, we all acknowledge that there's a skill shortage. Every industry's got a skill shortage. We have this requirement to install over 600,000 heat pumps a year, and we just don't have the workforce to do it. The workforce that is doing it currently isn't really skilled enough, in my opinion. The refrigeration air conditioning contractors don't want to do domestic work. That's an issue. Splits are more efficient than monoblocks. That's a fact borne out by physics, even if it's a bit controversial maybe. So we really should be encouraging the split units more than the monoblocks, but as you pointed out in the presentation, there are some issues with installations. And if you're going to have the heating engineers doing the installations, then they really need to understand the kit better. They need to understand that the lower flow temperatures for a longer period of time running is the way to get the efficiencies up and keep the running costs down. Because if they don't understand that themselves, they're not going to be educating the homeowner at handover properly. And that's where I think we get a lot of the issues with homeowners not running the systems properly and then incurring the high energy costs. So yeah, lots of challenges.
Okay, we'll kick that one into the discussion arena, which would allow us to see nicely the whole area of training and skills. Mr. Harmer will come in. So, Paul.
Yeah, thank you very much. Thanks for the presentation. Yeah, I'm Paul Harmer, lead technical consultant at the Chartered Institute of Plumbing and Heating Engineering. Just briefly, we're an educational charity, and our purpose is to look at protecting the safety, health, and welfare of the public through professional plumbing and heating installations. So yeah, the CIPHE, I mean, our focus is around that installer consumer connection, that co-design, making sure the consumer has an efficient installation, safe and efficient installation, and then making sure the installers can we'll say design and specify and install a professional heating system. So we've been working on, we go back sort of 4 or 5 years when we brought industry together, the low carbon group, CIPHE, boiler manufacturers, heat pump manufacturers, and we came up with this, let's focus on the system. Rather than the heat source, let's get the system right, so it's low temperature ready. Let's get gas boilers condensing, because over time we've sort of, you know, it's been great technology, but it's more forgiving than where we're going at the moment. So we probably, from a skills perspective, totally agree with Graeme. It's not necessarily an installer's fault, but obviously they haven't necessarily had to carry out all of that training, such as heat loss, but it should be a prerequisite. So yeah, we pulled together and agreed that we need low temperature heat systems as a standard. New build, easy. Retrofit, more challenging. But looking on the presentation, Iain, he spoke about manufacturers supporting installers by having a design. But one of the key things here is the installer is the surveyor. So he is that individual, that individual that's collecting it. They need to know what they're collecting to then supply it to the manufacturer to do a correct design. So it's that garbage in, garbage out effect. So the CIPHE's position is we've developed a low temperature heating and hot water qualification. We'd like to see, we are technology agnostic, we'd like to see system training, we'd like to see more move towards mandating low temperature in retrofit, but we understand the challenges. Even if it takes me back to the condensing boiler days, where we transitioned from standard efficiency to condensing, there was this exemption, you know, maybe some means of signing something to say, well, we can't make this low temperature ready, but this is why. But coupled with some training support as well from government. But yeah, that's sort of our position. And thanks again for the presentation.
Thanks, Paul. We'll be bringing you back into the discussion in a minute. There's some stuff about training and that kind of thing coming on the wires. But we'll let Dave introduce himself, because there'll be a few questions around the policy side.
Yeah, hi, thanks. And thanks for the presentation, Iain. Lots of familiar stuff in there, and some great stuff happening on the manufacturing side, it seems, as well. So just sticking for a moment with Europe, actually, I think the scale of the challenge in the UK, as that graph that you put up at the beginning of the presentation shows, Iain, is significant. But I don't think we should be scared of it, because if we look across to the continent and we look at what's going on over there, and these are not my numbers, these are from the European Heat Pump Association, but the European market for heat pumps grew 34% last year to 2.2 million unit sales, and is predicted to grow even faster this year. Last year, just picking France as an example, 537,000 units were sold in France alone. that's 24% of the total European market, with the UK market last year estimated to be around 45,000, less than 2% of the European market. That's interesting because it's not only a similar population, but much of the French housing stock is in a similar condition to the UK, particularly the rural housing stock, and yet France seem to be doing it. In August alone this year, 148,000 heat pumps were sold. That's just in 1 month. So these are just a sort of smattering of stats from the continent that show what's going on there, and just sort of give us a picture to answer the question as to whether this is possible. But I think in the UK we do have some Achilles heels for this industry, and we need to be honest about those, and we need to tackle them. Now, the first and the obvious one is the upfront cost difference between particularly a retrofit heat pump and a retrofit boiler. I think it's important we make a fair comparison between those two, because we're often comparing the cost of a well-designed, well-specified and quality and efficiently operating heat pump system, because you can't get away without doing that with a heat pump. And that's often, I think, incorrectly compared to the cost of a simple take a boiler off the wall and put another one on there, without really paying a great deal of attention to the rest of the heating system that you're plugging that into, and all the things that Paul was talking about in terms of the CIPHE's low temperature course and the need to get flow temperatures down. People don't routinely go around and do heat loss calculations when they change a boiler to check if the radiators are capable of operating at preferably between 40 and 50 degrees, which is where you start to get the peak efficiency performances of condensing boilers. That doesn't happen, and certainly if those return temperatures are above 55 degrees coming back into a boiler, that boiler cannot condense, and you're losing at least 10 percentage points of efficiency and wasting a lot of gas. So we need to be making a fair comparison of those price differentials. Now, having said that, a heat pump contains more components than a boiler, so even taking account of all those heating system considerations, I'm not sure we are anytime soon going to get over a difference in factory gate price between the two comparative boxes. Having said that, we just did some analysis for the Heat Pump Association of the October 2022 price cap, the gas and electricity, or the energy price guarantee, to give it its proper name. And what we are showing is that even against a fairly favourable performance assumption for gas condensing boiler performance on average of 87%, a heat pump operating at a COP of 3.5, an SCOP, that is a year-round coefficient performance of 3.5, a heat pump is going to cost around £350 to £400 less than a gas boiler to run at those prices. And if energy prices carry on going up, as they're probably expected to once the energy price guarantee runs out and gets revised again next year, then that running cost differential between a gas boiler and a heat pump is set only to get wider. The other Achilles heel that I think we need to face up to in the heat pump industry is the risk of poor performance, and that is straight back to correct specification, correct installation, getting the flow temperatures down to a level where a heat pump can operate efficiently, and making sure that we do as much as we can to eliminate the poor practice of trying to plug a heat pump into an existing heat system without doing those heat loss calculations and resizing emitters where that is necessary. Then I think, and I'm sure we'll come back to policy issues in the questions, so I won't go into those, but just one thing I think we do need to tackle, and Graeme touched on this, and I just want to add strength of view to this, is myth busting, particularly in the press. It is an urban myth that heat pumps only work in really tightly insulated and airtight homes. The truth is a heat pump can work in any property you like. It's just a question of whether it is designed, installed and commissioned correctly, whether it is sized, whether the emitters are sized. Just because you change a heat pump for a boiler, or a boiler for a heat pump rather, it doesn't make the building any less leaky. That building was leaky when it had a boiler in it, and if you can't tighten up the fabric efficiency of the building, there are other things you can do. You can change the radiators so that you get enough heat loss from those radiators at the low flow temperatures that allow a heat pump to operate efficiently. The boiler that was in there was operating inefficiently beforehand. You can put them into any building you like, provided that you pay proper attention to the other things that you need to do to the rest of the heating system. And I think that is a myth that we do need to tackle. We should tackle fabric energy efficiency, of course we should, but that is a technology agnostic given anyway. Even if you're changing a boiler, it's sensible to insulate draft proof and have whatever provides the heat operating to as little energy use as possible and at its highest possible efficiencies. So I'll stop there. I could rabbit on about policy all day, as many of you know, but I'm sure we'll come back to it in questions anyway.
I'm just looking at the series of questions, Dave, and yeah, we could probably do this for 4 hours, but we're trying. Part of this is to try and get these questions answered in as efficient a way as possible, because there's a few out there. There's a couple of themes that are coming through strongly. One is how do we get the message to, not surprisingly, how do we get the message to the customer, and how do we get them fully on board, and then how do we get the question, how do we get the challenge over to the installers as well? Some specific questions. Now you'll notice that Hamid is there in the corner. I am going to bring him in a minute. He will get his presentation as well soon, but just to let you know, I'm not ignoring you, Hamid. There's some questions which will be fired at yours and Ian's way in a second. The first one is just to clarify a bit about how the approach of splits and monoblocks, how you see it from your point of view. Are we mainly splits? Are we mainly monoblocks, or is it case by case basis? I think there are some installers out there who don't yet work with refrigerant who are asking the question.
Yeah, I can jump in, Andrew. I mean, interestingly, Dave mentioned the French market there, which you know is probably, if not the biggest, one of the biggest heat pump markets in Europe. And in France, there's a lot of refrigerant split heat pumps that are installed. It's probably, you know, 80-20 refrigerant splits to monoblocks, whereas in the UK it's the other way around. It's probably 80% monoblocks and 20% refrigerant splits. And I think that's really due to the skill set of the installer base that we have in the UK. You mentioned earlier, or somebody mentioned, it might have been Graeme actually, you know, air conditioning companies who are used to dealing with refrigerant and not working obviously in the residential sector. They tend to work more in the commercial sector. We would certainly encourage them to take a look at the residential sector. But I think that's why we have more of a monoblock biased heat pump market in the UK as opposed to some of the other European markets. Effectively, they both do the same job. They both provide heating and hot water. As Graeme mentioned, physics dictates that a refrigerant split system, you know, is going to be slightly more efficient than a monoblock system, but ultimately they can both provide heating and hot water. And we certainly, as Daikin, look at the advantages and disadvantages of both. And we certainly want our installer base to be able to speak to a consumer, because let's be honest, consumers don't want to talk to you about, am I having a monoblock? Am I having a refrigerant split? Am I having a hydro split? They don't care. I want a heat pump and I need it to do this. And some consumers might say, I do want that heat pump to be down the bottom of the garden behind the garage because I don't want it against the house. That lends itself to a refrigerant split. They might say, you know, I don't have a lot of room inside the house, so I don't want an internal hydro box. That lends itself to a monoblock. They might have a favorite installer that isn't F-gas certified, so that lends it. So we certainly encourage our installer base to be able to offer, you know, a monoblock heat pump, a refrigerant split heat pump or a hybrid heat pump, so that they can have a conversation with the consumer and say, okay, what do you want? I can find a solution to meet that, and whatever comes with that solution. So yeah, at the moment the market is probably 80% monoblocks in the UK, to 20% splits. But we certainly at Daikin would always encourage people to look at that refrigerant split option.
Thanks. Specific question here. If we're retrofitting to blocks of private flats up to 4 stories where there are currently individual gas or electric boilers, what are the proposals to convert this type of building? Is there a heat pump option? Who's going to tackle that one?
Shall I jump in on that one?
Go on then.
Yeah.
I don't mind who answers.
Well, I think the answer is there are a range of solutions, from very small individual monoblock units at one end of the spectrum to ground source heat pump solutions where you've got one set of boreholes or one set of ground loops that can then feed multiple compressor and condensing units, and in effect it's a district heating system. So you can have, and in fact there are a couple of HPA members in the ground source market that do exactly that, single ground loop, multiple property feeds. So there's a range of solutions that exist. I mean, it's down to a proper sort of engineering assessment of a building like that to get to grips with what's the most suitable.
Thanks, Dave. Yeah. I guess what I'll say to that is there's an opportunity for ground source heat pump question time, I'm sure, in the future. We're open to offers. Hybrids. Now, hybrids. What's the feeling on hybrids at the moment? So the boiler upgrade scheme doesn't take them into account. Is that right?
Yep.
But there are places, there are plenty of applications where they will work well. What's the feeling about that?
I think I'll certainly jump. I mean, we could do a question time on ground source. We could definitely do a question time on hybrids. But I'll keep it short if I can. But for me, I think not having hybrids on the boiler upgrade scheme is a mistake. One of the biggest challenges the UK is going to have is the retrofit market. We have existing properties that are relatively poorly insulated, a lot of microbore pipe work, lots of gas combi boilers. There's about 14 million plus gas combi boilers in the existing UK housing market. And Dave mentioned the upfront costs of switching from a heat pump to a boiler. The only thing people can compare with is take that combi out, put another combi in. For most installers, that's probably a day's work. Drain down, disconnect, new boiler on. I'm not saying a day's work is the right amount of work it should take, but that's pretty much how it pans out. And so a lot of the upfront cost is around upgrading, the pipe work, maybe looking at radiators, certainly adding a cylinder. Whereas, a hybrid heat pump you can bolt a hybrid heat pump to an existing combi. And what I think the boiler upgrade scheme is saying to consumers is, come and join this energy transition, this low carbon transition. But by the way, you've got one choice. You either rip out your boiler and put a heat pump in and take into account all those extra upfront costs, or you stick with another boiler. So there are opportunities with hybrid to reduce some carbon, not as much as a full heat pump, but reduce carbon, introduce consumers to what it feels like to live with a heat pump, albeit in combination with your boiler. But also, some of the upfront costs in getting a property ready for a heat pump can be done over the period that they've got your hybrid in. So for example, I'm installing one in my place, and I recently decorated the living room. I had to take a radiator off, so I'm just going to put a bigger radiator back on. And maybe when I decorate another room, I'll upgrade the radiator in there. So I'm providing the opportunity now for me to lower the flow temperature and increase the heat pump output. I'll improve the insulation in my house because it needs to be done. But I'm not doing it all in one go ready for the heat pump. I'm doing it over the period of time I've got this hybrid. And all I'm doing every time I'm making those improvements, I'm improving the heat pump coverage. So I'm improving my carbon saving. I'm managing my running costs. I'm managing my running costs because I've still got the boiler and the heat pump working together. So I think there's a lot of advantages for hybrid. It's not we have to move to the full heat pump, but in terms of this transition, it does give us a transition technology. So yeah, I think there's a lot of opportunity for hybrid if we think about it a bit differently.
Thanks. So there's more of a general question. I'm going to bring Graeme in on this, and that is, I guess, putting your question back to you, which is, how do we address the myths? How do we ensure, get the message over in a coherent way, both to installers and to the end user? We've heard a little bit about how one house builder is being persuaded, but what does the industry do? What does the industry do, Graeme?
we keep on banging the drum, and I think to me, you're just going to keep on banging that drum until people actually start to listen. I've really frustratingly in the last kind of 4 or 5 months, I've been interviewed by Financial Times, The Guardian, Times, Sunday Telegraph, and I've been educating them. They've specifically reached out asking for comments about heat pumps, and I've given them facts. I've given them examples of heat pumps working really well. But instead of actually them writing a story covering that, they've perpetuated the myths because they'd rather go for that snappy soundbite, the clickbait that the press all seem to be going for nowadays. Not the trade press, obviously, Andrew, but the mainstream press. And as long as they continue perpetuating that myth, we've got a problem. I don't know how to get across that really. I think I've spoken to government before about advertising. They will spend millions on advertising some things that they want to advertise. Why aren't they doing this? Why don't we see on television adverts paid for by the government explaining about the benefits of heat pumps? Because that's the sort of thing that will get through to homeowners. And until we start getting that kind of messaging out there, so that the homeowners starts to drip feed into their subconscious, then we're going to have a problem. But I don't. Other than that, I don't know, because I've been trying to do it and speak to the press for a long time.
So certainly from my point of view, I think that one of the key things that trade publications particularly, but manufacturers and installers as well can do, that the national press won't do, is to provide case studies that are detailed. So that also helps the installers see what's going on, the contractors see what's going on, and then it can help explain. But
it does.
You're right.
But you actually got to get them to read the case study. This is the trouble. Because you're right. There's a lot of great case studies out there, but they tend to be read by people who already know the subject. They're not read by homeowners generally, and it's the press that needs to be reading them and understanding them. I think this is one of the key issue.
I think we could do with some tours of successful projects. Maybe we set those up. Paul, have you got a view on this?
Sorry, on the
conveying the message, getting people on board. But I think we do need to think about installers as well when we're thinking about this, because we all know that there are some installers still who just don't think it's worth it, and that's another challenge to overcome.
Yeah, I think the installers are the conduit, one of the big conduits. They're in the house, they're in the consumer's property day in, day out. So it's critical that we install confidence in the installers. That's number one, because they have a personal relationship, a lot of them, with the customers. It's all based on reputation. It's that little local economy. And that's going to take time. I think we can't avoid the pains, Andrew. The pain, whenever. We're not saying that heat pump technology is disruptive. It's been around for many years, but we're going through that early adopter phase. And, we need to make sure that there's good messaging between consumers to encourage them. So-and-so down the road had one installed. They've had a great experience, and a lot of it's I think down to that education again. Not just mainstream have a responsibility. I agree with Graeme. It's easy just to read the headlines and go for the doom and gloom. It's good to see industry, technology working together, and I mean the fighting between technology seems to have calmed down. We seem to be accepting now that this is where we're going. It's a common goal. But for the CIPHE, we really focus on that front line, and we need to work with installers. You know, being an ex-installer myself, I remember the challenges trying to promote new technology, especially when it's more expensive. So we've got to not only teach them, you know, how to install it, but we need to teach them the benefits of it as well. They need to be advocates, and we're seeing a lot of it now with which is great to see, this low temperature thing going on online now since the policy changes, where consumers are starting to turn their boilers down. I'm hearing it more and more now. Installers calling and saying, Paul, I turned a commercial property down to 55 degrees. It's great, you know, it's actually working, you know, and the consumers are starting to accept it. So it's a long sort of journey here. But, you know, for me, yeah, industry needs to pull together really, you know, so yeah.
Thanks, Paul. I'm going to switch it over to Iain now, because there's a specific question, because you've made the mistake of saying that you used to be a small contractor. So people now want to know, what advice would you give? Put yourself in the shoes of a small contractor now. Yeah, how it is. There's a lot of information. We've proved that today already. A lot of information coming at them. There's a lot of costs. There's a lot of paperwork. How do we hold the hands of the smaller firms?
It's a really good question, and I do think about it a lot. Obviously, from my time as doing that, and even when I was doing that, we did install a few heat pumps, and I think a lot of installers know that we need to start getting ready, you know, for this transition. We need to sort of get on board. All I would say is make that move. You have probably a decent business now, you know, installing heating and maybe plumbing and heating, maybe in the residential and commercial sectors. There's nothing to stop you carrying on with that business, but start to introduce, you know, the option of a low carbon heating system. I think good installers for the future will be able to go and visit a customer and give them some options. You know, Paul, Dave, and Graeme have all mentioned it. You know, we've got to look at how we design systems and how we install systems correctly, not just the one bit of technology, which is either the boiler or the heat pump or whatever. But if you're an installer now out in that market and you get an inquiry off somebody to put a new boiler in or a new heating system in, why not go along there and say, yes, I can put a new boiler in, of course I can. But do you realize, you know, maybe this is the last boiler life cycle change that we're going to see? And you know, we're getting consumers now buying new houses, and they've got maybe this house here built by this builder with a heat pump already in, and this house here by this builder with a boiler in. And they're already starting to think, probably when that boiler dies, I'm going to have to put a heat pump in. And all the additional costs that we've just been talking about will have to be absorbed by them. If I buy this house now, it's already got a heat pump in. So that's taken care of already. So I think my advice would be, if you're an installer, start looking at it now, because if you go and speak to a consumer about a heating system, they can throw a stone from their window and find somebody that can install a gas boiler. They won't find so many people that can offer them a low carbon solution. So it gives you an edge in the market. It gives you the experience. So you're starting to get used to installing heat pumps before the market really does explode. And find the right partners. And that's not just an advert for Daikin. Genuinely, you know, take the time and go and find the right partners. But, you know, find a product that you like, that it's sufficient. It's relatively straightforward to install. It can deal with most house types. Find somebody that can help you with leads and opportunities, because it's one thing to say, I want to make the switch to heat pumps, but where do you find that heat pump work? Because that's where you get your experience, you know. So, you know, find somebody that can help you, and maybe we need more installers, maybe push some leads your way, give you the right support to get going. But yeah, make that switch, start offering it as an add-on to what you would normally offer. I think you will see people who are interested in that. So yeah, that would be my advice, to start thinking about it now.
Thanks. A couple of people have got their hands up, so I'm just gonna we'll come back to you folk in a sec, and then Hamid we'll kick in with the presentation when we've tackled the rest of this subject. So Dave, you're on next. You got your hand up.
Yeah. So just responding on the last two questions, really. So first on myth busting, what can we do? Just to add to what Graeme said, there are some good myth busters out there already, and some heating industry veterans who have got some excellent material already out there on places like YouTube. So I think some of us in the industry have got a responsibility, manufacturers, some of the big contractors and so on, to take a look at that and use it in their own marketing material, bring it to the attention of government, and bring it to the attention of journalists to say, look, the not necessarily the trade press, but mainstream journalists, to say, actually, what you're reporting on here is nonsense. You know, here are the people who really know what they're talking about. Spend 30 seconds looking at this quick explanation from one of these people who have been around and who are good communicators. So that's point number one. The second is just to build on what Iain was saying, in terms of today's installers. There's 130,000 gas safe registered installers on the books at the moment. We can't do this without them. It's unrealistic to think that we can. We're going to have to tap quite deeply into that wealth of existing experience and expertise in heating. Many of them have already been through the core plumbing and heating training, where back in the day they would have been taken through things like correct radiator sizing, heat loss calculations and so on. So for many, even if they haven't had to do it because the 30 kilowatt combi condensing boiler has made it very easy to ignore all that for the last 17 years or so, since it came in, much of it will just be top up refresher training to get them to a point where correct system sizing is revision of something they'd already learned a long time ago, rather than doing a deep sort of bottom up training exercise. And the government is due to I guess flex its muscles a little in this respect soon, because it's going to be consulting later on, early next year, we think, on something called mandatory technical competencies, which will be a requirement for competent person schemes if people wish to continue self-certification under the building regulations. They will need to be able to certify to these mandatory technical competencies, and I think we can expect to see some toughening up of the requirements around efficiently operating heating systems in those mandatory technical competencies, not just, hugely important though it is, looking after the safety requirements which gas safe and Offtech have done for so long. You know, it's time that there was some regulatory underpinning behind efficient heating system use. And then finally, just to say that the other thing is that the government should be encouraged, as it did when we made the switch to condensing boilers, to come forward and offer to help with the training of the early bird adopters. You know, so for those who want to brush up their skills and get into low temperature heating and indeed heat pumps, let's press the government for some sort of training voucher scheme to pay for the first ones that choose to do so. So if you've got both approaches, if you've got if you set the expectation that we are going to change the regulations, so you have to do this, but let's say the first 20,000 of you that jump in, you'll get your training paid for, then I think you create a kind of upfront incentive among many installers to want to get in early, particularly as Iain has said, they've got a more profitable business model the sooner they jump into doing so.
Can I just come in on that, just to point out that actually BESA have funded, they funded the BESA Academy to, we actually trained about 1,500 heating engineers to upskill them already, and we've actually just received last week confirmation that we've got another tranche of funding from them to do another 400 or 500 engineers, I think it is. So they are, it's a start, you know, it's at least a couple of thousand engineers there that wouldn't have had the opportunity for the upskilling before. But yeah, they need to do more, definitely.
Yeah, I think definitely the challenge at the moment is that they're pretty tight timescales for not only for the boiler upgrade scheme, but also the other schemes as well, and also net zero. That's a tight timescale. We haven't really got
Sorry,
time
Andrew,
to wait.
I should just add that in terms of training capacity within the industry, we do not see any constraint there whatsoever. The manufacturers that sit on the exec of the Heat Pump Association, their training centres alone, the manufacturer-based training alone, could scale up to training 40,000 installers a year very quickly indeed. And we've polled them. We're pretty confident of that figure. So capacity is there. It's the motivation to do it.
The motivation and making the finances work, of course, is a key thing.
Exactly.
We often have installers saying, well, if I'm taking a day or 2 days out of my day and my week, then that's going to cost me in the long run. So it's squaring those circles. Paul's had his hand up virtually for a long time, so I better let him in.
I've been so patient.
You've been surprisingly patient, Paul. Well done. So you're on the stage.
Yeah. No, the key one for me is obviously we're talking about 600,000 heat pumps per year, or within a year in 2028. That's what, a third of the gas boiler market we would assume. And I've been told that 70% of gas boilers are through a distressed purchase during the colder months and 50% during the warmer months. So that's one of the biggest challenges that we face with heat pump adoption, is how do we get a heat pump installed in a distressed purchase? One of the key things for H&V News to keep their eye on, if I were just to advise you on something here, is keep an eye on the BESA Heat Pump Ready Innovation Programme.
Okay.
I've been involved with that the last few months, and I can say that there's going to be some exciting stuff that comes out the back of it, especially on the technology and tools, which will hopefully assist in moving a heat pump installation towards to be achievable in a distressed purchase. So I think it's the journey towards 2028, whether we reach it or not, that target. But I think there's some exciting stuff that probably industry doesn't really know about, and probably won't know about for a few years.
Wow.
But keep your eyes open is what I'll say there.
Excellent. Thanks. Now, I'm conscious that, talking of being patient, that Hamid has been waiting to do his presentation. So let him do that. There will be a second set of discussions after that. I should also say that to all those who've been writing their questions in, that we will, if we don't answer them live, they will be in the box for our panelists to read, and I'll do one of those guarantees that all your letters will be read. Okay, over to you, Hamid. We'll all fade away into the distance and let you start away.
Thank you, Andrew. Before I start the presentation, just a quick introduction. So I am Hamid Salimi, not Samidi. So Hamid Salimi, product specialist for heating and renewables at Daikin, UK. So just to put it very simply, my job is to introduce and launch our heating, renewables, and residential products, so ventilation and small AC products, but in particular air to water heat pumps. I also work with our R&D teams, our factories, so the European Design Centre, which Iain mentioned earlier. The main reason for doing that is to get the feedback from our installers, our end users, our customers in the UK, and design products specifically for the UK market. So we talked a lot about the simplification, the consistency. Obviously, there's a bit of confusion about the different types of heat pumps, hybrid, high temperature and low temperature. And the aim is to make or design the products which are more specifically designed for the UK market, for the small houses that we have here in the UK, and hence this presentation. So I will talk about a specific product, and I'll also try. I've been reading your questions, so I'll also try to answer some of those questions whilst presenting. So this is about a specific product which we call our true monoblock, so a Daikin all-thermal low capacity monoblock. And the main theme of the presentation is how we can simplify the installation of the heat pump to overcome the challenge, which is switching from boilers to heat pumps. So let's just begin. Before I start the introduction, I'll start with the very basics, and I'm sure you'll know this, but this is just to set up the scene. What is a heat pump and how does it work? So as you know, heat pump is the reverse of cooling or refrigeration. And refrigeration means the removal and relocation of heat. So it's just simply removing from the place where it's not wanted to the place where it's objectionable. With the heat pump, we do the opposite. So we grab the heat from the place where it's not wanted to the place where it's wanted. And we do this with the help of a refrigeration cycle or refrigeration circuit. So we have a refrigerant, we have some components. The bit which sits outside in your garden or on the roof is the evaporator, where evaporation takes place and hence the heat is absorbed. And then that's taken to the indoors by the refrigerant and the compressor to the condenser. So that part which is inside the property is the condenser. That's where the refrigerant gas condenses, and by doing so, it gives off all the heat which it just absorbed from outside, and it will give that heat off to either air or in this case water, and the water is then used to heat the space or give you hot water for your domestic hot water usage. So that's how, to put it very simply, that's how a heat pump works. Now we have different types of heat pumps. So we have air to water heat pumps where the heat is absorbed from air. We have ground source heat pumps where the heat energy is absorbed from the ground, from geothermal. Obviously we can absorb that energy from water as well, so water to water heat pumps. And then we have hybrid heat pumps, and that's the terminology which is used where the heat pump and another source, e.g. a gas boiler, for example, will work together. So either one or the other or together to provide you the required capacity for the house. Just a bit more detail about the refrigeration circuit. So as you can see, in here we have we are showing the monoblock kind of design where the refrigerant is concealed within the outdoor unit. So the refrigerant will obviously do it absorbs the heat and it brings it back to the condenser, and then it will transfer that heat into the water, and then anything within the building is the water. The water will then go into your circuit, into taps and showers for the domestic hot water use. Now, we can use different designs. So we can use a monoblock, for example, where the refrigerant is concealed within the outdoor unit. Someone talked about I think there was a question about handling of refrigerant. So with the monoblock, you get a concealed refrigeration circuit, which means that you don't need any HVACR gas certificate to break into a refrigeration circuit. We have hydro split systems where the same happens again. So the water side is within the property and the refrigerant side is outside, concealed within the outdoor unit. And then we have refrigerant splits where an HVACR gas certification is required to do the installation. These are some typical COP performance figures from the heat pump. So it's just for you to understand what we can expect in terms of the efficiencies and COP from heat pumps. So the heat pump COP is obviously higher compared to, say, a gas boiler, but it depends on various factors. So it depends on, as you can see horizontally, we have the outdoor temperature. So when the outdoor temperature drops, then the COP, or the coefficient of performance, drops. And when the temperature goes up, then the COP goes up. It also depends on the leaving water temperature that you want to get out of the unit. So if the system gives you a higher leaving water temperature, then the COP reduces. And if it's the low leaving water temperature, then the COP goes up. But there are many types of heat pumps. We have the splits, as I mentioned before. We have refrigerant splits, hydro splits. We have monoblocks. We have the single fan and the twin fan outdoor units. So why are they different? And then we have the small cylinder or domestic hot water heat pumps with the ducts. We have hybrid systems. We have high temperature and low temperature systems. And although we know the fact that there are horses for courses, and it depends on the project what sort of heat pump is required. But the main idea is that the simplicity is required. And I think the industry needs more simplicity. Installers need more simplicity and consistency if they want to switch from boiler to heat pump systems. So to make things more simple, the design is the monoblock design, or a true monoblock design, which obviously will make your installation, the control and design of the heat pump simple. The monoblock design, or a true monoblock, is something which we introduced with our products. So we have, for example, Daikin Altherma R32 low capacity monoblock, which we just introduced, but the similar designs are offered by other manufacturers. And as Iain mentioned before, it makes up to 80% of the market in the UK because of its simplicity. It's simple, it is one component, and it's suitable for the UK homes. So with this product, for example, it uses R32 refrigerant. It's compact, very small dimensions, plug and play concept. It only comes with the user interface, which has WLAN as standard. And it doesn't need any sort of indoor unit. So except for the tank, which is used with the heat pump, you don't need to install anything within the property. So again, that will give you more space. That'll save you space. And all you need to do is to put an outdoor unit somewhere in the garden. For the improved serviceability, there is a rotatable switch box, for example, which again makes it easy for the installer to complete this job and move on to the next job, save them time. The product is high efficient. Again, to increase the siting flexibility, this monoblock can be installed up to 30 meters away from the tank. So traditionally, there is a very small limit, 5 to 10 meters between the monoblock and the tank. Now that's increased to 30 meters. So again, increasing the flexibility, the siting flexibility for the unit. System covers sizes 4, 6, and 8, comes in single phase, heating only and reversible. So again, Part O regulations and overheating in the buildings can be overcome in some instances with the system, because it has the reversible element, so it provides both heating and cooling. Just a few more things just to explain how the system is simple. So again, as you can see, a redesigned casing, small product, which can be installed under a windowsill, which can blend with any sort of decor. A renewed fan shape means that the system is very quiet. So noise is one of the issues or one of the myths. We talk about myth busting, but with improvements in technology, so with the renewed fan shape, for example, and the grille which hides the fan, further reduces the sound of the unit. So those days are gone when we used to say that the heat pump in your garden is going to be very noisy. So now we are talking between 40 and 45 dBA, which is a very low sound. The system is a true monoblock, which means that all the hydraulic components are within the outdoor unit. So again, there is no need to purchase any other additional hydraulic components and then think about installing those components within the property. Everything stays outside and it saves space for the occupant in the property. And obviously, we've introduced the product with advanced controls to make the installation and the commissioning much easier. Now, in terms of the product range, again, the product covers typical 4, 6, and 8 kilowatt, or sizes 4, 6, and 8, which at UK conditions at -2 degrees outdoor and 45 degrees leaving water temperature will give you slightly higher capacities in most cases. They are available in both reversible and heating only options. And as I mentioned before, there is nothing needed apart from the tank and the user interface and a thermostat. There is nothing needed to be installed within the property. So again, a very simple, easy installation with less components. So just to go through the features, advantages, and benefits of a true monoblock system and how it makes life easy for the installers, specifiers, and end users, obviously during this switch between from boilers to heat pumps. So firstly, when you look at the true monoblock design, it's all-in-one design. As mentioned before, so all your hydraulic components, your plate heat exchanger, expansion vessel, pump, flow switch, they're all within the outdoor unit. So again, there is no requirement for the hydraulic components to be installed within the property, so less time required on the installation and more space saving. Obviously, when it's installed with the tank to provide a full space heating and hot water, then the system will give you the benefit of 2 key components. So you will have a monoblock, which stays outside, and you will have a tank, which will go inside the property in, say, airing cupboard or utility rooms. Again, this is a major benefit. So nothing else, like no indoor unit, no expansion vessel, no pump, or anything is required to be installed within the property. A few months ago, we did we carry out periodically Gemba visits with our customers. So this is part of the study that we carried out. And according to that, the questions that we asked and the data that we received was that about 61% of the installations, heat pump installations, in particular tanks, are installed within the airing cupboards. And within the UK, a typical airing cupboard is between 0.5 to 1 square meter. So they are very small. And majority of the installations or majority of the components will go inside the airing cupboard. So the airing cupboard may be able to take a tank and a G3 kit, but there may not be enough space for all the other components. So that's why we need 2 components to put the outdoor unit outside, and then a tank within the property and in that airing cupboard, for example. We also have a pre-plumbed cylinder option. And again, this is not just us, most manufacturers have pre-plumbed cylinder option, which is, again, as the name indicates, it's a cylinder which is pre-plumbed. Again, based on the surveys that we carried out, this saves installer more than half a day. So between half a day and 3/4 of a day is saved by installing the pre-plumbed cylinder. So everything is fitted onto the unit. Again, when you connect it with the monoblock, you will get the two-part solution, one part outside, another part inside. But in this case, you will have everything fitted onto the unit. So again, it's the simplification and make the installation easier for the installer and quicker for the installer because everything is fitted onto the unit. The system also has a buffer vessel, for example, which can be used as a hydraulic separator if the hydraulic separation is required between the primary and the secondary circuit. And that's pre-fitted onto the pre-plumbed cylinder. Again, the pre-plumbed cylinders on the market, most pre-plumbed cylinders that I've seen have got onboard pump for the secondary circuit. So again, you're saving space because the onboard pump is connected onto the pre-plumbed cylinder, which is used to pump the water between the primary and the secondary circuit. And all the other components like your magnetic filter, automatic air vents, immersion heater, and everything is pre-fitted onto the pre-plumbed cylinder, making installation easy for the installer. Another challenge that we face is siting the domestic hot water cylinder or tank, or the position of the cylinder from the monoblock. So a typical house would be where you put a monoblock outside the house in the garden, and then the domestic hot water tank will be somewhere on the first floor in between the rooms in the airing cupboard. So if it's a slightly larger house, then it will definitely exceed the distance of 10 meters, 10-meter limit, which used to be a norm in the industry. What we've done is we've increased that distance from 10 meters to 30 meters. So now the domestic hot water can be sited up to 30 meters from the monoblock. Now the installer will need to carry out the calculation and engineer the pump within the monoblock, but there is a possibility to site the tank up to 30 meters away from the monoblock. So again, giving installer and specifier flexibility to size the tank or site the tank up to 30 meters away from the monoblock. With the monoblock, sizes 4, 6, and 8 all come in standard casing. So again, it makes the installation easy, and it avoids questions like why is someone else's product bigger than my product, or why is my product bigger than someone else's product. It works really well with the new build applications with multiple properties where the heat losses are different, where say sizes 4, 6, and 8 are used. But when you look from outside, all the outdoor units look the same. So again, it makes the installation easier, and it reduces unnecessary questions about the size of the product. We talked about the controls earlier. So with the monoblock, most of the heat pumps that are offered in the market, the controls are more developed nowadays. So the control that we offer, or the controller that we offer with the monoblock, is the user interface, or MMI user interface, which is used for day-to-day usage by the end user, but it can also be used by the installer and by engineers to do the commissioning. So the commissioning, for example, can be carried out from start to finish within 9 easy steps, and it will just take 5 to 10 minutes to complete the commissioning. For multiple sites, for the new build properties, for example, if same commissioning parameters are used, then the user interface has a USB slot, so the commissioning or the field settings can be transferred from one side to another side. Again, this will save installer much time rather than standing next to the controller every time and spending 5-10 minutes. They could just transfer the settings from one controller into another controller. The controller is supplied with the WLAN card or this SD card as a standard. What that means is that the card is inserted into the user interface, and then it can be connected onto the through WLAN onto the router within the property, and the user can then communicate with the heat pump via an app called Onecta app. By doing so, they can change the parameters, switch the system on or off, raise their hot water temperature from wherever they are. So they can control and monitor their system from wherever they are. Most importantly, they can monitor the energy usage of the product. So earlier we talked about the myth busting, and one of the things that I've that we see that manufacturers up until now have been given data which is a measured data, but sorry, a calculated data, but not a measured data. I think we need to be measuring the data of how much energy the heat pump consumes rather than the calculated data which is in the lab, for example. So with this control, for example, you can measure how much energy is consumed by the unit and how much heat output is given by the unit. So it will give you the true indication of how much energy is consumed by the unit, which is, for example, installed in Scotland, certain conditions for a certain house with a certain heat loss figure, rather than calculating the figures which are measured in the lab. This monoblock is supplied with the rotatable switch box. What that means is that
Hamid, are we coming close to the end of the presentation because we're running out of time?
I'm very close, yeah.
Okay, right.
So the system has a rotatable switch box, which is, again, as you can see, it's very easy for the installer to get into the hydraulic components and service the system. Again, there is a possibility with most of the products to reduce the minimum water volume within the system, again, saving them space. So they don't have to put a volumizer or anything, because the system can operate with 0 liter minimum volume, and it will carry out the defrost by using energy from the hot water tank. Quiet mode, we talked about the sound. Again, most of the products on the market are much quieter now, and same is the case with this monoblock. It will give you a sound of 40 dBA, which is again same as a library or birds chirping, so very low noise. And finally, just a couple of slides just to finish this. So the system can be connected to the smart grid, which means that you can connect the system without any adapters to PV panels. So make the most of the energy produced by the PV panels to heat or cool the space or heat your water. Again, we offer the product with a full list of accessories to give a one-stop shop to our customers. So if they have a specific project where they need feet or hoses or brackets, they can get everything from one manufacturer and have a peace of mind that they don't have to go to various parties to source these products or these accessories. And finally, just to finish off, the product, and again, it's the case with most manufacturers, but this product is on MCS database, on key mark listing, on ENA under connect and notify. So again, less work for the installer. They can install the unit and then notify the network operator. And it's on the SAP listing, so for the SAP assessment. So again, we've put the product on all these databases to make it easier for all the 3 parties, specifiers, installer, and end user, to install a product and complete the job. Thank you.
Fabulous. Thanks very much. Now, Hamid has got a bit of work to do because there's a lot of specific questions. And I will let him type the answers. I think that's the best way to do it. So if you want to look down your question box, Hamid, there's quite a few specifics about the product. But we haven't got a lot of time. We've only got 15 minutes now. And I want to try and address some of the other general questions. So bring back the panel, seeing them emerge. There's this might be one for Iain, might be one for Hamid, it might be one for Graeme, I don't know. A couple of questions about, or clarification required about refrigerant qualifications. Now, if you're maintaining a monoblock, do you need to have the F-gas qualification because you'll be breaking into the system, or is it more complicated than that? Who wants to tackle that one, Iain or Graeme? Or
I can do that one, I guess.
All right.
You don't need to have the F-gas qualification if you're not breaking into the refrigerant circuit. That's how the law stands. Having said that, one of the reasons why we developed the heat pump awareness course for upskilling heating engineers is actually make sure they understand what is in the copper pipe, because we have heard of stories of heating engineers going to a system that isn't working properly and they think there's a blockage in the pipe and they've cut the copper pipe and the refrigerant's leaked out because they see a copper pipe and think, well, that'll be water.
Right.
You know, these things have happened. So they don't need to have the F-gas qualification, but they at least have to understand that there is refrigerant in the system, and I think understand how the system actually operates. So yeah, there are F-gas awareness courses that aren't actually F-gas qualification courses, which I would probably recommend heating engineers to take if they're not actually going to do the full F-gas.
Yeah, I think it's important to stress, as one of our regular correspondents has made the point today, that refrigerant is a substance that only certified engineers should handle. So we'll make that point, and we'll also make that point for the benefit of the installers who might be thinking about heat pumps. And Daikin and other manufacturers have plenty of routes to that skills and training as well. Skills and training, let's just cover that off here. Maintenance has been raised as again, we just touched on that as, you know, one of the key issues, because we're talking about installation now. That's the important first step, but maintenance and service equally important. Yeah, Daikin, you have a view on that? Iain, you got plans in place for the maintenance side, hopefully a few years down the line, but
yeah, absolutely. I think it's crucial. It's as well as, you know, making sure that you get the maximum life out of your system. It's also making sure that it's running as efficient and, you know, as efficiently as possible. So, I mean, unlike a gas boiler, you know, there's no legal obligation as such in terms of you know, natural gas, but it's for Daikin, for example, you know, it's part of our warranty conditions that if you want to maintain the warranty, you need to have it serviced and maintained annually. You will also have an unvented cylinder 9 times out of 10, so that needs to be checked. But yeah, we already have maintenance contracts that end users can take up with us, but also we want to encourage our installer partners to start looking at that as well. But I think, as you say, it's get the installation right first, and then we can start looking at maintenance. But it's a big opportunity as well.
Part of the picture, isn't it? It's all part of the picture. Excellent. I want to deal with one specific question, and then we're getting to the point. We're going to look at final thoughts. So we've got a question in from an architect, and he says he or she is having difficulties in motivating clients in terraced houses, particularly, to switch to heat pumps. And of course, as you gather, the main criteria that comes up is the space and needing area for a big amount of plant in the garden, heat pump, and potentially water cylinders. What is the industry doing to address the space issue?
So, I mean, I can just, something that interested me recently, seeing a post about heat pumps in the loft, and extracting the air and having ducting and going, like a vertical flow of a gas boiler. I saw something recently. I'm not sure if it was in the H&V News, actually. Yeah. So, yeah, I mean, I don't know what manufacturer specific, but it's probably one to ask the manufacturers here. What about the potential for heat pump technology to be placed in the loft?
It's again.
You might shoot me down here, but
no. It's Daikin, Netherlands, for example. They do a lot of that already in the Netherlands, particularly on new build. So they are installing the heat pumps or the outdoor units basically on the roof. But there's a hatch so that you can access it from inside the loft. So you don't have to get on the roof to maintain it. You can access it from inside the loft. We did a small project ourselves a few years ago where the client did ask for us to put the outdoor units in the loft. There was a lot of challenges, none more so than a cold ceiling, because you're bouncing cold air around that loft. You get a cold ceiling, condensation on the ceiling. So then they had to duct the intake and the outlet. So it starts to add a lot of cost. But yeah, certainly in the Netherlands in particular, Daikin are starting to install a lot of heat pumps in the loft. I've seen heat pumps on prefabricated timber frame buildings where they've effectively made a cutout in the frame, so the heat pump just basically sits flush with the wall. You just have to make sure there's enough airflow around that space. Obviously, it takes up some space in the house, but it means it's flush with the wall of the building. So yeah, there is a lot more questions. Even things like cylinder space. Companies like Sunamp, who are using these phase change materials to generate hot water, which means you can have a much smaller unit than the cylinder. So yeah, there's a few things going on, but yeah, I think Dalway was probably the company you're thinking of that were testing a house with a heat pump.
Yeah, which reminds me of the exhaust air heat pump days. That was all.
Yeah. Again,
so that the size of a heat pump outdoor unit is sometimes an issue, but it's not as big as all that anymore, is it? It's reduced in size quite significantly recently. Am I right?
Yeah, I mean, again, physics and engineering, there's certain, you do have the certain components that you have to have in there, and there's a certain size heat exchanger and fan, etc., that you need in there. But I mean, recently the twin fan units have been reduced to single fan size. They're still quite big, but you haven't got the height then to worry about. And also, again, when we talked about refrigerant splits and monoblocks, a refrigerant split outdoor unit is typically smaller because you haven't got all the hydraulics in the outdoors, but then you have to find room for for a hydro box or something indoors. But most places are used to having a boiler on the wall somewhere, so the hydro box can just take the place of the boiler, typically. So yeah, there is options, and again, we're constantly looking at trying to make things smaller. But it's good capacity as heat losses drop, and you can make smaller heat pumps again. So fabric first is always a good approach anyway, because the more you can get the heat loss down, the better it is, really.
Great. So we're now at that point where I'm going to ask you to give me your final thoughts. What's the one thing that we're going to take away? Apart from we probably need an extra 2 hours for question time on heat pumps. But we have got an awful lot of information out over the ether in the last couple of hours. For those who've missed the beginning and want to review what's been going on, we will put the recording up and send it around when it's available. I'm sure Iain would be happy for the presentation, the slides to be distributed. So that's good. So then, you're all going to be waiting to see who I go to first. I'm going to go to Graeme first. What's the one takeaway? Yeah, there you go. Well done.
One takeaway. We've probably given more problems and answers in this 2-hour session. I think a lot of it. I think one key thing that Hamid touched on, I think, in his presentation, that is a really key takeaway for me and all of this is the controls have to be really simple. We need to make them idiot-proof. Frankly, a lot of householders really struggle with, or have done with some of the controllers. The manufacturers have used kind of air conditioning style controllers for the setup and the commissioning and stuff like that. Now I'm fine with that because I was an HVACR installer for years before I came to work for the BESA. But a lot of householders will really struggle with that, and I think, with respect, a lot of heating engineers struggle with it as well. So it needs to be as idiot-proof as possible.
Excellent, thank you, Paul.
Yeah, so for me, it's creating a fair market. So looking at the system, whether it's a gas boiler or a heat pump, the same level of due diligence and effort and design goes into a gas boiler as it is for a heat pump. So, you know, people, I hear it in conversations, how do you bring the cost of heat pumps down? And then someone will pipe up and say, well, actually bring the cost of gas installations up. And I'm like, oh, what do you mean? No, let's make them condense, yeah? And the same for a heat pump, let's make a heat pump efficient, let's get that system right. So for me, it's tackling that one with some sort of policy and training support for installers, because it's, you know, it's a big change for them.
Thank you. David?
I think the takeaway for me, looking at the questions, and I think we've got 22 that we haven't managed to answer, but the big takeaway from me is that there's still a lot of work to do to get the message across, and the questions that are being asked there, we are familiar with. We've been working up and rehearsing the answers to those questions for a number of years now. And the good news is that those answers do exist. It's a communication exercise, together with, I guess, a partnership effort between industry and government to bring about some policy change to nudge this along. But many of the issues that are raised in those questions around things like certification, routes to market, and so on, we do have the answers to those. We've got good ideas. The conversation with the government on bringing those about is further advanced than many might realise, and keep talking to us, because we're keen to communicate how that transition can take place in an effective way, so that we can get fossil fuels out of heating over the next decade or so.
Thank you. Okay, so now the invidious task for Daikin folk is, you've got 3 minutes between you. So do you want to give me one sentence, Hamid?
Okay, so I'll because Iain has done most of the talking, so I'll take this. So as a product manager where I stand, I think to me the most important thing, and we've already started working on this, is how to make the products more simple to install and simple to operate, and also to help how to help with the myth busting. Something that David mentioned earlier, it was the cost of using heat pump versus boilers. We've started doing this, so I'm running 5 test projects in different homes, old and new homes, on hybrid and heat pump systems, just to measure how much it's going to cost to install them, how much it's going to cost to run them. So it's not the calculated figure, it's the measured figure. And working on those figures and publishing those figures will actually help the end user and the installer to understand the heat pump, different types of heat pumps, and making it simple, just a 2-part system or one-part system for something to give you space heating and hot water.
Thank you. There you go, Iain. You've still got 35 seconds left, so you can have your final say.
35 seconds is the easy one for me, Andrew. we just need to get on with it. We just have to get on with it. And there's some questions in there from Neil, and I agree. It's the whole supply chain that needs to get on with it. You know, we can't single out installers or manufacturers. We all need to be part of it. So, you know, there's solutions there. Yes, there's more work to be done, but as I say, if we can get installers just putting it up there as an option, just to start off with for consumers, law of averages says there will be consumers that will take you up on that option. If we can get manufacturers continue to do what they do, specifiers continue to start considering it as an option, and distributors looking at that as an option, then, you know, we can continue to push. But yeah, we just have to get on with it. It's that simple for me.
Thank you. And I think, yeah, from to round this off is to say that talking about it is as amongst us as an industry is the first thing we need to do. Try and pull in the same direction. Events like this are what helps. It gets the information out there, gets people talking, gets people asking the questions. And we've seen today on the question boards that some people have very big questions, some people have very specific questions. They all need answering if we're going to further low carbon heating. So thanks to Daikin for that. I'm going to ask my organisers to keep the question box open for Hamid to do his we can't allow all these specific questions to go unanswered, so you're going to have to type away in the typed answer box for a lot of those, I think.
Sure.
But that way everybody, most people will at least get their questions answered. As I say, we will be writing this up. We'll be doing sending the recording round, and let's keep talking, everybody. But thanks to the panelists, thanks to the presenters. It's been a very good session, and let's do some more. Thank you very much, and thanks for tuning in and being interactive. That's what makes Question Time the event it is. See you soon.